Divergence of a vector point function. Suppose we have v is the differentiable vector point function. Then divergence of v equals del dot v, where del is the operator which is defined as I into dou by dou x plus j into dou by dou y plus k into dou by dou z, where I, j, k are unit vectors along x axis, y axis and z axis respectively. Suppose you have v, which is a vector function, has the components v1, v2 and v3. Then we have v can be written as v1i plus v2j plus v3k. When you perform the dot product between the two vectors del and v, we have I into dou by dou x plus j into dou by dou y plus k into dou by dou z gets multiplied to the vector v1i plus v2j plus v3k. Since we have I dot I equals 1, j dot j equals 1, k dot k equals 1. Also, since we have I dot j equals 0, j dot k equals 0 and k dot I equals 0, we will have the final output for this vector dot product will be product of terms dou by dou x of v1 plus dou by dou y of v2 plus dou by dou z of v3. Thus we will get this output which is free from ijk, and hence the resultant answer is a scalar quantity and not a vector quantity. If you consider divergence as a machine, then we have divergence receives a vector quantity of this format as the input and it displays always a scalar quantity as the output. Curl of a vector point function. Suppose v is a differentiable vector point function, as in the previous case. We have curl of a vector equals del cross v, that is, it is the cross product between the operator del and the vector quantity v. Therefore, we have the definition I into dou by dou x plus j into dou by dou y plus k into dou by dou z will have a cross product with the vector v. Suppose we have the components for v defined as v equals v1i plus v2j plus v3k. Then we have curl of vector v equals cross product between the vector quantities del and vector v. This is actually determinant of ijk, dou by dou x, dou by dou y, dou by dou z, which comes from the definition of del, and the last column constitutes the components of the vector v, which will be v1, v2 and v3. By usual determinant expansion, we will get this step. Notice that the output received when you evaluate curl of a vector quantity is also a vector quantity. That is, if you consider curl as a machine, it receives vector as the input and it displays vector itself as the output. Both the input and the output are vector quantities. Let us consider a cuboid or a parallelopiped or any region along which a fluid is flowing. Then we have the physical meaning of divergence will be, if v represents the velocity of the fluid, then divergence of v equals rate of outflow per unit volume at any point of the fluid flowing through the region. Which means that divergence gives us the idea about how much of fluid is flowing outside per unit volume. If we have divergence equals 0 in any region of space, then we will conclude that the corresponding vector quantity v is a solenoidal vector point function. When you evaluate curl of a vector, you are actually measuring rotational moment of the corresponding vector. If you obtain curl of a vector equals 0, then it would mean that the corresponding vector is irrotational vector. That is, it does not undergo any kind of circulation. Whenever you have curl of a vector is non-zero, then you will conclude that the corresponding vector is rotational vector or it undergoes circular movement.